action.
Time to shine, people. It's number 23.
He's probably playing his mom.
Keep your close to the
No,
wall.
no, Luke is like a fall.
So,
Oh, is Jonesy coming?
Yeah, I'm gone.
Oh.
I'm not here.
dang it.
Sorry, I didn't see you coming. It's not by me. So this is an adding problem. We can only add and subtract like terms. So we need to simplify each term and see if there are any that are alike. You guys remember how we do this?
You can.
Yes.
There's an invisible 2 right here, so we're going to do 4 divided by 2,
That's 2.
which is 2. And 3 divided by 2 is 1 with a remainder of 1. So that means 1y comes out, 1y stays behind. Z is basically 1 divided by 2. Doesn't work. It's like a remainder of 1 basically. So if the power is smaller than the root, then you just leave it alone. So Z stays behind, guys. Okay, and then on this middle term, what's the square root of x squared?
X.
X. 2 divided by 2 is 1. So 1x comes out. What about the x that's already there?
Just multiply, so it's x squared.
Right. 1 comes out, 1's already there. X times x is x squared. Okay, and then the yz, just like this z over here, is too small to get out. So they stay in there. Alright. And then the last one, this is almost the same thing. Square root of x squared, the x comes out. Like 2 divided by 2 is 1. 1x comes out, there's an x already there, so 6x squared, square root of yz. Are any of these like terms?
Yes.
Which,
The first 2.
the first 2. Almost the third one. The third one, what's the third one lacking?
A y.
A y. So what is one of these plus one of these?
2.
2 of those.
Nice.
And the other thing just stays the same. How far should we try to get today? Maybe we'll get to
40.
35. Get to 35, then I'll let you guys work on the evens.
Sounds good.
That's not a lot, but that's fine. Okay, 25. Oh boy, 7 times 3 to the x. It's kind of a weird one. I don't know if we did. There's not a lot to this one. Does anybody want to guess what it is? Okay. Yeah, it's like terms. We have 7 of these minus 4 of the same thing. So how many of these 3 to the x's do we have? 3. 7 of them minus 4 of them equals 3 of them. Okay. That actually simplifies a little bit because these are both 3's. What's 3
So 3
times 3 to the x?
3
4 to the x?
No.
2x?
Here, okay, quick question.
X
So is it just 3x? Oh.
Plus x plus 1. Or 1 plus x. That's all we can do. That's kind of a weird one. Is there?
It's kind of a weird.
Yeah, I don't see any evens that really match that one. So fortunately, it was an odd. Okay, 27. All right. What do you guys think on this one? Probably the easiest way is just, since they're both square roots, you can multiply those together. So, what is 6a squared b cubed times 3ab?
18a to the third, b to the fourth.
Yeah, still in the square root. And then we're going to simplify that square root like we were doing with the other problems. Square root of 18, if you're not, since it's just a square root, you could use your calculator for that. But it's basically going to be 3 square root of 2. Okay, then the a's, so we got an invisible second root right there, so we're going to do 3 divided by 2, 1 with the remainder of 1. Then for the b's, it's 4 divided by 2,
So that's 2.
which is 2 with no remainder. Alright. Number 29. What kind of problem is number 29? Foil problem. Not only is it a foil problem, here's the bonus question. What kind of factors are those?
Conjugates.
Oh, Nick. You get the bonus points in my heart.
Can you please make
On
my
my
grade
lab,
go
it's
up? I'm
worth
suffering. Okay.
Okay, yeah, these are called conjugates. What's special about multiplying conjugates together?
The middle part disappears.
The outside, inside cancels out. So really, you could all do the whole foil, but really you only need to do first and last. So if I multiply the first together, 1 times 1 is the last. Square root of 3 times negative square root of 3 is negative 3. You could say negative square root of 9, but square root of 9 just becomes a normal 3, right? Anytime you multiply a square root times itself, it just becomes that number. Anyway, 1 minus 3 is negative 2. When you multiply conjugates, they can get rid of the weird square root stuff. That's why they come in handy, because we're going to have to do that on number 33. 31. Okay, it's 3x plus square root of 7 squared, which means we're multiplying that thing times itself. Yeah, it is a FOIL problem. Whole thing times itself. So the first is, these are not conjugates because they're both plus, not plus minus. So we have to do double FOIL. What's 3x times 3x?
9x squared.
What is outside? 3x times square root of 7. Yeah, I can't really do anything with that. Inside is the same thing. And then the last, square root of 7 times square root of 7. 7. Can we simplify? Yeah, we have 3x squared is 7 plus 3x squared is 7 is 6x squared is 7. I'm heating up.
You're what?
I'm in the zone.
For the math zone? I thought you were born in the math zone.
That's true.
The grind doesn't stop.
I'm on fire. Okay, 33. Okay, remember that you're not supposed to leave square roots or radicals in the denominator. And so like on number 32, you could get rid of that square root of 18 by multiplying the top and bottom by square root of 18. Actually though, on 32, before I did that, I would reduce square root of 3 over square root of 18. But on number 33, there's two terms, so you can't just multiply by square root of 5. You had to multiply by the conjugate. Some calculators can do this one. If you just plug in the original equals. Cooper, you're in deep meditation.
Ty just keeps staring at me and it's annoying the correct at me.
You did the same thing to me
No,
earlier.
he's just sitting here like,
You literally did the same thing to me earlier. You have no
I was asking for a calculator, you were just in the middle of a conversation.
He just thought that he was like,
That's a little strange.
Alright,
He doesn't have to be. He can stay yellow. No. No, he wants to stay that way.
leave it.
He's
Yeah, they're
staying cool.
scared.
He's staying
Alright.
wild.
Anyways, the multiply at the top we got 4 times 1 is 4 minus 4 times square root of 5. And the bottom is a FOIL, except since they're conjugates, we really only need to do first and last. 1 times 1 square root of 5 times negative square root of 5. Okay, 1 minus 5 is negative 4. Can I do anything else? Yeah, you can divide both of those by negative 4. You can't just divide one term, you have to divide everything by negative 4. So 4 divided by negative 4 is negative 1. And negative 4 square root of 5 divided by negative 4 is positive 1 square root of 5, or just plus square root of 5.
I think it's kind of switch sides. Like you go on that side on this.
maybe you should just switch sides.
There's no C over there besides high. Nobody wants to switch side high.
You could be staring at you next.
He's your next victim. He's your next victim. Here's the next victim.
Just think, dude, you could be over there and get pet your hair.
Ty is a bit of a liability.
A bit?
Why are you staring? Or no, it's just top. I turned around. Okay. Did I ever tell you guys
So
about Billy?
weird. It is.
No.
It gets free, dude.
Billy.
It gets worse every time.
Billie Eilish?
Like,
No,
Oh.
bro.
Billy Eilish?
Eyelash.
That's not real music. Also, it's real.
Oh.
Okay, actually, after we do this one, I probably should talk about 36. Okay, I remember that equals like the square root of negative 1, but you're not supposed to leave it on the denominator either. How do I get rid of this one?
Flip it.
I don't, well, not flip it.
I mean, like, you
Conjugate.
Multiply by the conjugate
You
again.
know what?
I don't know, I'm not sure if calculators can do this one.
it can't.
You can't.
Because of the eye.
Some calculators can do eyes,
I think they
but
Did I will.
A problem this big, I'm not sure.
Whatever happened to your carbon fiber one? That one doesn't.
David, in case you're wondering, my calculator that you stole from
Doesn't
my
do it.
desk, it
Yeah,
won't do it.
I know.
Alright, so the top is an actual FOIL problem. So we have to do all those times all those. So we gotta do first, outside, inside, last. So first would be 4 times 1. Outside 4 times 2i. Inside 1 times 3i. And last is 3i times 2i. What's 3i times 2i? 6i squared, which becomes a minus 6. Remember, I squared turns into a negative 1. So anyway, instead of plus 6i squared, it's minus 6.
Simplify.
And then the bottom, I'm going to go ahead and do the bottom. It's also a FOIL, but we can just do the first and last. First is 1 times 1. Last is negative 2i times 2i is negative 4i squared,
Positive 4?
which turns into a plus 4, yes.
No, you're not.
Mr. Bell thought so.
Okay, so on the top,
I was smart.
That makes more sense.
so on the top we have 4 minus 6. I did see Mr. Bailey yesterday.
So he's a lot. That's great.
And then 8i plus 3i,
Yeah, that's pretty good.
and then the bottom is 1
How
plus
does that look,
4.
Craig? You got something to say?
David, did he ask for your attitude?
Yes. Are you seeing these kids? Look at that. What do you think, Craig?
What do you do?
Say it.
He's thinking you're a retard.
I think we all are.
Hey, that's not a nice word.
I didn't say it.
That's not a nice word.
I know, I
You
said
said
it.
it.
I'm so sorry after.
I'm gonna go tell
Alright,
you
does this simplify?
No.
No. A lot of times, I should mention this because it might be on the test someday. They split the i's up into the real part and the imaginary part,
No.
like that. Not all books do that, but I think it's more common to see it like this. Both of these are okay, but anyway. If your calculator gave you an imaginary answer, it'd probably look more like this one. You guys see what I did? I just put them both up over 5. Okay, 36 is a little bit weird, so probably should talk about it. There's a lot of weird stuff going on. 6 divided by, okay, yeah, let's write. Whoops.
You can just like make that piece bigger. Scroll in.
Yeah. Alright. 3 to the 1/3 is the same thing as what?
Cubed root 3.
Yeah, it's like 3 to the first, cubed root of that, so it's basically just the cubed root of 3. So it's 6 over cubed root of 3.
Can't have.
But we're not supposed to leave the radical in the denominator. But does multiplying by cubed root of 3 solve my problem?
No.
No, because it would be cubed root of 9. Does 9 have a cubed root? No, it doesn't. What does have a cubed root though?
27.
20. Yeah, if I multiply by another 3, cubed root of 27 is 3. Instead of doing times 3 though, you could just say times cubed root of 9. To make it a little bit simpler. So the top is 6 times cubed root of 9. And the bottom, 3 times 9, 27. What's the cubed root of 27? Normal 3. That's why we did it, to get rid of the radical. Okay, anything else?
Yes, it simplifies.
6 and 3, right? Alright, I want you guys working on these evens. Celine, I did record yesterday if you wanna watch that sometime or whatever.